a relic of the typewriter age. Every day, you press the same keys without thinking. The first 6 letters spell QWERTY, a pattern older than electricity. It feels random, but it isn't. It's the product of trial, error, and the limits of 19th century machinery. Billions type on it today, yet almost no one knows why it exists or why it never changed. In the 1860s, people wanted a faster way to write. Letters were copied by hand, and offices were drowning in paperwork. A newspaper editor named Christopher Latham Sholes in Milwaukee began experimenting with a mechanical writing machine. Each key connected to a thin metal arm called a typebar. When pressed, the arm swung up to strike an inked ribbon and leave a mark on paper. It worked, but it jammed. If 2 nearby typebars hit too quickly, they tangled in midair. That small mechanical problem would shape how the entire world types. Sholes' early prototypes used alphabetical order. It seemed logical, but it failed immediately. Words like the and locked the machine because those letters sat side by side. Every few seconds, the arms collided. So Sholes began rearranging. He spaced common letter pairs farther apart, forcing typists to alternate hands. To do that, he used data from printers about which letters appeared most often together in English. He kept changing the pattern until the jams nearly disappeared. A layout that slowed you slightly produced higher overall speed because the machine finally kept up. By 1873, Sholes finalized a pattern close to what we use now. He sold his patent to Remington and Sons, a company famous for rifles and sewing machines. They had the tools to mass-produce precise metal parts. Remington's Model No. 2 typewriter debuted in 1878 with one revolutionary feature, the shift key, and another, lasting one. QWERTY, the letters across the top row, read exactly as they do on your keyboard today. Once Remington printed instruction manuals and typing charts with that pattern, the layout became default. Every typist learned it. Every rival company copied it. Momentum turned one engineer's workaround into a global standard. Some claimed faster speeds, others fewer errors, but switching layouts meant retraining workers and rewriting manuals. By the 1890s, typing schools standardized around QWERTY. Manufacturers, teachers, and secretaries all reinforced one another. The more people learned it, the harder it became to replace. Economists later called this a network effect value, created simply because everyone uses the same thing. Early typists watched their fingers and used only 2. Then, in 1888, court stenographer Frank Edward McGurran introduced touch typing, memorizing the keys and typing without looking. He practiced on a Remington QWERTY and dominated public speed contests. Typing schools adopted his method, locking QWERTY even deeper into professional training. From that moment, the layout was no longer mechanical. It was a form of muscle memory. In the 1930s, psychologist August Dvorak studied typing fatigue and designed a more ergonomic layout. Common letters sat on the home row to reduce finger travel. Tests showed higher speed for trained users, but QWERTY's installed base was already massive. Even when the US Navy tested Dvorak keyboards in the 1940s, the results were mixed. Offices refused to change. QWERTY had become a habit larger than logic. By the 1950s, computers replaced typewriters, but engineers kept QWERTY. Programmers and office workers already knew it. Teletype machines, early word processors, and IBM keyboards all reused the same arrangement. Even modern shortcuts like Ctrl+C and Ctrl+V were built around those positions. When laptops and phones arrived, designers simply shrank the keys. Today's keyboards can't jam, yet we keep the same design, because the cost of unlearning outweighs the benefit of change. In economics, this is called path dependence. Once a path dominates, each step forward makes reversal harder. QWERTY isn't efficient, it's inevitable. As Remington exported typewriters, other countries adopted the layout with minor edits. France shifted a few letters to make a QWERTY. When computers spread worldwide, local versions kept those bones. Even languages using non-Latin scripts, such as Taiwanese, mapped their characters onto QWERTY positions. The pattern became a silent alphabet of modern communication. QWERTY looks random, but it hides structure. Vowels and frequent consonants alternate between hands to maintain rhythm. In the original typewriter, each letter, S typebar, sat in a circular basket. Arranging frequent pairs apart prevented collisions inside that circle. On today's flat keyboards, the design appears arbitrary, but inside the first machines, it was precise engineering. Typing isn't just mechanical, it's neurological. After enough practice, your brain builds a map of motion paths rather than letter locations. You don't think about where A is. Your fingers simply go there. That reflex made QWERTY nearly unbreakable. Each generation passes the habit to the next. Children learn it in school before they learn cursive. By adulthood, it feels natural, even though it never was. History is full of standards that survive for similar reasons. Railway gauges, screw threads, electrical outlets, none are optimal, but all are entrenched. Once industries, tools, and education align, the system becomes self-sustaining. The QWERTY keyboard is one of the purest examples of technological inertia. It stayed not because it's best, but because it's everywhere. QWERTY shows how small design choices can outlive their purpose. A fix for jamming typebars shaped global communication for more than a century. It connects the industrial age to the digital one, a straight line from iron levers to touchscreens. Technology often keeps its ghosts. We don't always adopt the perfect solution. We adopt the one that spreads first. The next time you type your name, remember, each keystroke is part of a 150-year-old story. A story of engineers fighting jams, of typists memorizing keys, of computers inheriting a pattern built for metal arms. The layout that once slowed people down now connects the planet. It's not elegant, it's persist, and in technology, persistence often wins. Thanks for watching Foo Fun Facts. If you enjoyed this episode, like, subscribe, and tell us what everyday object you want decoded next. Maybe why pencils are yellow, or why airplane windows have tiny holes. Your idea might be our next video.